Hey, welcome back. We're going to try to finish up section 5.5, the logarithmic equations. This is a slight shift in gears. That's why I wanted to start a new video here. It was also getting a little bit long. But on number 7, we actually start with a logarithm that has a variable on the inside of the log. So we'd like to know what is the thing. So 6 to what power? Let me just go ahead and convert it. 6 to what power? I'm sorry, 6 to the 2 power. Remember, logarithms are exponents. 6 to the 2 power is x, which tells us the answer. X equals 36. So there's no hard work there. Just what do we mean by that logarithm? Now I'm going to start showing you some logarithmic equation manipulation here, instead of just thinking it through like that. Let's look at our next example. Number 8, log of x equals -4. Now this is a base 10 common logarithm, so let me just show you a little trick here. What you do is, to get rid of a logarithm, you raise it as an exponent on the base, the base that identifies with the base of the logarithm. So this makes this 10 to the -4. These will kill each other off, leaving you just x. So you get 1 over, and then 10 cubed is 1,000, so this must be 10,000. This is 1 over 10 to the 4th. So x must be 1 over 10,000. And this is a type of an exact answer. So 1 over 10,000. All right, great. Let's keep going with our logarithmic equations here. On number 9, we have a base of 5. We have a variable inside there and a 2. So you apply the logarithm that will get rid of it, the one that will be the inverse of it. Okay, and so this cancels that, leaving you just 4x minus 7 equals 25. Don't forget to apply the base to the other side as well. Remember, 2 is an exponent. 2 is the exponent on the base 5 that makes that happen. It's an exponent here as well. And so final answer on that one is x equals, so you add 7, you get 32 divided by 4, which is 8, I believe. So got a nice answer there. 8 is a solution. And that's something you can check on your calculator. Make sure you got a good answer. Let's do a few more of these. There's quite a few. I don't think we're going to have to do all of them. Let's see here. All right, let's do number 10. So it's the same kind of tricks from here on out. These are common logarithms, and here we go. Now, before we can get rid of this logarithm, we've got to bring them together. Remember, the sum of two logarithms is the product of the two logarithms. That's step number 1. Step number 2 is to get rid of the log by raising it as an exponent on that base, because that will kill that logarithm, make it go away. So then you're left with just x times x minus 3 equals 10. Now don't forget that 10 to the 1. That really messes up answers if you don't do that. This is x squared minus 3x minus 10 equals 0. This does factor, I believe, into 5 and 2 and negative and positive. And so you get x equals 5 and negative 2. Now here's a this is a good example, because this kind of stuff creates what we call erroneous solutions, and we have an erroneous solution right now. So you got to go back and check your answers. So here's our check. Let's do x equals 5. This one actually works. You get the log of 5 plus the log of 5 minus 3 is supposed to be 1. And you can just actually check it on your calculator. Just type it in. Log of 5 plus log of 2 and just see if it comes out to be 1. And it does. It verifies. But not the second one, the log. So if x equals -2, log of -2 plus the log of -2 minus 3 equals 1. Well, you're going to find out right away that it's not, because you can't take the log of a negative number. There are no numbers that when you raise them to an exponent, it makes them into a negative value. It's impossible. So there is no base e. So, sorry, base 10. If you have base 10, there is no exponent on the positive base 10 that turns it into a negative. So there's no solution. These are undefined. And these logarithmic equations create stuff like that. You've got to look out for them. So there's a single solution, and it is 5. All right, that was a really good example. I liked it. Next couple are very similar, so I'll leave those to you. So let me just skip down to, let's do 14. So it says use a graphing calculator to solve. So you can actually, we've been doing a lot of things precisely, but you can actually solve these things on the calculator. So x, e to the 2x. I'm just typing in the equation here, -2. Now that's the left-hand side of the equation. So look at number 14, by the way. And now I'm going to put the right-hand side of the equation right here. And so the question is, when do these equal each other? For what values of x does the left-hand side equal the right-hand side? We're just going to graph on a standard window to start off with. We don't really know where they're going to intersect. Hopefully it will. There it is. Bingo. It's right there. So let's, now you may not have used this before. So when you put the left-hand side in y1 and the right-hand side in y2, this first curve there is the left-hand equation. The second curve is the right-hand equation. And it's a constant. That's why it looks that way. Now, when you hit second function trace, you get to the calc menu. We're looking for number 5, intersect. Now it's going to ask some questions. So I'm looking for the intersection between these two curves. It's going to ask first curve. You just always hit enter as long as you just have 2 functions in there. Second curve, it'll go to the second curve. You just hit enter. And then guess. Now there may be multiple intersections. There's only one in this case. So I'm just going to hit enter again, and it's going to go find it. It found the intersection. Got to be careful what it says. The answer is x equals 0.803. 0.803. That is where these two intersect. They have the same value 2. The right hand side is 2, and the left hand side is 2 as well, when x equals 0.803. I'm going to copy that into our working homework. Edit, paste. All right, does that make sense? Hey, it's been fun. I'll do another couple videos on chapter 9. Man, the semester is almost over. Keep up the hard work. Take care.